Hello and welcome to learning more about fabric. Today I have Steve Campbell with me. Steve and I are going to go through some details around lake houses and what they are made out of, how do they work, just some conceptual pieces. So take it away, Steve. It's great to have you kind of talking about this topic.
Yeah, thanks very much, Mike. As Mike said, we're going to talk today about some lake houses. We're going to take it very conceptually, and this is the first part in a series to kind of understand lake houses, delta, and fabric. It's going to be very low code, no jargon, any of that. A nice high level overview to kind of understand what all these things are, what these words mean, kind of get an idea of what's happening under the surface.
Love it. Let's get the slides up and going.
Awesome. All right. So first, we're going to talk about really what is this data lakehouse thing. But to do that, we kind of have to introduce a couple of concepts that we'll go through. So the first is taking it back to a data warehouse. And we call this data warehouse. This is typical things that have been around for quite a long time. This is what we do in SQL. You know, they often run on the SQL language. So we call this structured, right? So within this data warehouse, we normally have something like, or to build this data warehouse, we have something like a SQL server, which is kind of the box. And then within this SQL server, we have some databases. And you can see this here in this little diagram. We have kind of a house with a SQL server, and we have these little databases. And then we build these things called data warehouses. And data warehouses are really structured. So when we use databases, when we use SQL, what we mean by structured is we have tables. So tables have rows and columns. Columns, we know exactly how many columns are in our table. Often they're very strict data validity around them. So for example, sales, we might only allow people to put numbers in here. And within these columns, they'll have things like constraints, so things like primary keys. So it's all very structured, right? We know exactly what the table should look like. And this is a good thing when we're building the data warehouses, because it's really easy to report on data if we know what it looks like. Obviously, if you try to open and do some reporting and you had no idea what the data was going to be, the columns change every time, that's going to make your job a bit difficult. So that's just kind of what we've had. And for a long time, we've had these data warehouses using SQL, right? These SQL servers and SQL databases. But then what about other formats? Of course, especially now that we're getting into this kind of AI era and lots more data is coming in. What about things like pictures and audio files, streaming data coming in all the time? And even unstructured data like emails and that sort of stuff. This is really what came about the data lake. And essentially, we want to have a way to capture lots of data that we're getting in newer formats like this, or at least formats that we hadn't traditionally been capturing, even not so long ago. So all of this, what we call kind of this more unstructured formats, where we can't really put these in tables. We don't know what's going to be in an email, pictures and stuff like that. Again, and then video, audio, all of this kind of stuff that we're doing a lot of AI on now. This needs to live somewhere too. And it's hard to put this sort of stuff in a data warehouse, but that's where we have a data lake. So essentially a data lake, really, if you want to take it very basic definition, think of it as a big storage container, right? Just somewhere where you can dump lots of data. You can save files, which are in all sorts of formats. You don't need to have any special rules specifically to add data, and you can have lots of unstructured data, lots of different data formats within it. So that is the data lake. So it's good for the structured or semi-structured and unstructured data. It's also really good for data science. Data science needs kind of all this data. It needs lots of data. It needs data in different formats. For example, image recognition. Of course, you need images. And what's one thing that has made data lakes very accessible now is that the cost of storage has kind of gone down dramatically. especially in the last couple of decades, right? So we can save big amounts of data, much more than we could even not so long ago. And that's what data lakes are really good at. And then finally, it's very quick to load data in. And this is quite an important part. We can get data into a lake very quickly because there isn't all this data validation as you would in a warehouse. So it's quite easy to pump data into this data lake. So this is kind of getting onto the warehouse and then the data lake. Before we go on to the data lake house, there's an important concept though on why we might want to use a warehouse and what sort of things have advantages in the traditional data warehouse. And one of this is called ACID, right? And this is an acronym. We're going to talk about what this ACID in databases is. So when we're talking about the data warehouse, the databases, why would we use these over this new data lake format? Well, let's have a look at what ACID means. To do that, let's go through a little example here. Imagine that we have a database which is a banking database, right? It's probably going to be a lot more complex in real life, but on the left, you have Steve's account here, and on the right, you have the store's account. And each row in this database is just a transaction. So in Steve's account, he's deposited $1,000 and then spent $100 in the second row. So in Steve's account, if you sum this column up, you would currently have $900 left in the account. In the store's account, right, there's $700. So what would happen if we wanted to make a transaction? So we're going to buy something from Steve's account. I'm going to buy something from the store. Well, there'll be two events that need to happen. First, you need to add this row to debit Steve's account $200. And then you need to add the row to credit the store's account $200. So these are two separate events that happen because these are two separate tables. But what would happen in this case? Let's say we debit the $200 from Steve's account, but then the servers go offline, right? There's something massive. The power goes down. Even cloud can be knocked offline at times, right? So something happens, the system shuts down. When it reboots, though, it's lost the idea of where it was in this transaction. So it's only actually managed to do the debit of Steve's account, but before the system could complete the credit of the store's account, it went offline and we lost this. So if that happened, it's in a really bad position here because we've kind of lost this $200. The store and Steve are both going to be really, really annoyed about this because there's been a fault in the system, came in a really bad time. These are two separate transactions that have to happen in the database, happened at this time. So what would happen in this case? So that is where this ACID acronym, and it kind of looks to overcome these sort of issues. And the first one is automicity. And so this basically says that all the statements can take place or the transaction doesn't happen at all. So it's talking about transactions. So in the case of the Steve buying something from the store, right? The thing with data warehouses, you can have the ability to say, this is a transaction. We need to have both of these two separate events, debiting one account, crediting the other. They're separate because they're happening to separate tables, but we can build in and say, this is automicity, right? Everything has to take place at once or has to be completed. Otherwise, it can roll back. The second thing we look at in this ACID acronym on databases and why we use databases is consistency. Consistency says all database rules must be observed, such as constraints. So constraints could be, we can't add text to a column which we've said is a numerical field, right? If it's dates, it has to be a date. And this is something we can do in data warehouses. We can add this database constraints and these column constraints, stuff like that. So this is a really key thing if we want to report. Obviously, if we have a column with some bad data in, right, that's going to mess up our reporting and really ruin when we try and look at this data. So consistency is a really important part. Another part is isolation. kind of no other processes can happen at the same time or interfere with the current process. So for example, let's have another look at this. Let's say in the same example that Steve's going to buy something from the store again. Now, as we said, there's two things that need to happen. We need to debit Steve's account and credit the store's account. Obviously, they're going to try and run at the same time, but they're probably not going to run, to the millisecond. There's always going to be some lag, probably. What would happen though if we said, okay, we credit the store's account, but almost simultaneously, before we run and before the next statements run to debit Steve's account, he's bought something somewhere else for $800. So Steve's tried to buy something in the store for $200. We looked in his bank. We said he had at the time $900. So we start running the statements. We credit the store's account $200, but then almost simultaneously, Steve spends $800 at a different store as well. Well, now he only has $100 in his account. So when we come to run this next one, we can actually see that this green process here in the middle has interfered, right? It's somehow slipped in between crediting and the store's account and debiting Steve's. So there isn't actually enough money left in Steve's account. However, the database has already credited the store's account. And obviously with billions of transactions happening a day, right? This could be an actual real possibility to happen. So that's what isolations we say. We need these processes and we can set them up in the databases and saying, you know what, we treat this as one. We can't allow this other stuff to interfere, and we'll be able to roll back and void the transaction if this was to happen. Finally is durability. We can just say, once complete, all the changes are made permanent, right? So it's written to disk is example, but say this is durable. No matter what happens, these are saved. These changes are permanent, and we can be confident that we're not going to lose them, in the event of something going down, something like that. So that is ACID, and this is one of the key reasons we would use a data warehouse, because this is a set of this acronym is a set of rules and things we can set up to protect the data quality and to make sure that the data and everything that's going on happens correctly. The data quality is good and really preserves the data. In that data lake, though, we basically said it's one big storage account. So it's a lot harder to do that in a data lake.
I want to jump in here real quick. So Steve, this is a great explanation of what an ACID transaction looks like in a warehouse. One thing I'll just point out here, this is a newer development in the concept of lakehouses. So lakehouses typically didn't have an ACID type transaction. So this is a very newer technology that the industry has just recently kind of adopted and started to building on top of this. This was one of the main stopgaps between using lakehouses many, many years ago. They didn't have this capability of being able to reliably and have consistent data coming through a process. So this is why Microsoft is taking the stance more towards these lakehouses, because this is a new technology that people develop. There's some simplification that is being made to this that allows any lakehouse to take advantage of these very common data warehouse technologies, features that we can now get inside a lakehouse. So I just want to point that out, that this is kind of the net new thing that we're seeing here. And this is why we're so excited about all the lakehouse experiences, because it provides so much normal data warehousing experience now inside the lakehouse.
Yeah, exactly. Really great point. And I think that segues really well right onto this data lakehouse piece. And to emphasize that point that Mike brought up, I'll say a data lakehouse is more of a concept than a physical thing, really. It's a data lake, essentially, with some thoughts around it and with some architecture and structure and kind of these, as Mike said, some of the newer features bringing into the lakehouse that make it a lake house. And essentially, what we had is we had this lake, which is just a big storage container, essentially, good for data science, as we said, this dump lots of data in. It's all unstructured, though. Then you have the warehouse. The warehouses are great for BI. We like SQL tables, we like tables. ACID compliance and strict data validation. And what we kind of say is, well, why don't we do this? Why don't we just merge the two concepts of taking the data lake and the data warehouse? Let's bring, and as Mike said, fairly recently development, bring all that compliance, all the ACID, all this good stuff from the warehouse that we've been doing for ages, and apply it to the data lake. And we're just going to come, merge the two techniques. We'll just merge the name as well. So now we have a data lakehouse. Really clever to kind of combine those, and you see where the name comes from. So that's the idea. This newer thing to really combine the benefits of both systems. And what is the difference between a lake and a lakehouse? I mean, obviously, Microsoft, as Mike said, is putting a lot of things into this. And if you look at something like Fabric, which we're going to obviously talk about mostly, this has a lot of extra stuff you can do in there and lots of settings. And then we'll go through kind of how that all works. But really what they're doing is putting some architecture around the data lake.
Yeah, this is something, if you think about this, when you move data around, you need a computer to move the data. To store the data, you're just storing it on a disk. And so, when I think what's the lake to lakehouse terminology, you now have to think about, okay, where do I store the data, and what computer will access and touch the data and change it and or manipulate it. And that's really what the lakehouse is. The lakehouse is the consolidated story of the evolution of the data warehouse, moving into more of a lake environment. And now we have many more options than just like a SQL server to talk to the data. And so we have more opportunity for us to build creative solutions that meet our needs, whether it's real-time streaming data, it could be structured data files or flat tables or tables that we need to go access. It could even be images or pictures, audio files. All of these things can now be utilized inside this lakehouse. And we think, data is growing exponentially. Every year, we're getting more and more video and audio and other kinds of content out there. And so as your organization is trying to look forward to what you need to be preparing for, is you're going to have to prepare for more data than just a structured data table.
Exactly. I really like that. The terminology, how you talk to the data, right? I think that's a great way of putting it there. So exactly. And all the different types of data that we now have and we now use. Generative AI and all of this, we're using much more formats than ever before, even in the recent several years, right? So,
and I see a really strategic moment here from Microsoft, and I really like this direction here. The direction is, you need to do data engineering today, so we're going to give you the tools to do it. But tomorrow, you're going to look at data science. Tomorrow, you're going to look at AI. You need a platform that can do those more advanced analytical things. And that is the foundation of the lakehouse. That is why we do this, because the tooling that you need to do the next generation of machine learning and AI and everything else, it's already built into the platform. And so this is why this is so incredibly important. This is like building the foundation of your house, the very bottom floor. You can't build the second floor of AI, machine learning, and predictive things without having lots of good, clean data. And that's why this is so exciting to us, because this is really going to change how the business views their data as a strategic asset now moving forward.
Yeah, exactly. I think it's a great buy-in for this data lakehouse concept, right? And saying we're putting the data here. Maybe initially we probably start with business intelligence and reporting, even just getting data out, putting data in one place so we can look at it in Excel, something like that. But then knowing that once we have it in this lakehouse, when the data's there, that's actually going to allow us to, as you say, to do this AI, to move on. We have the tools. It's all in the platform. It's there. So really,
this is where it gets really exciting.
Yeah. And you can tell me and Mike get very excited about this because we've been playing with it as well. So
yes, exactly right.
Really cool.
All right, back to your slides.
All right. Yeah. So data lakehouse. Basically looking to combine the best of both systems. Now, we can't really talk about a lakehouse without talking about some sort of architecture and layout. And one thing we do in a data lakehouse generally is we have something what we call layers. So because the storage is quite cheap, because it's easy, we have all these tools. Typically, we take things in a few steps, and this has a lot more advantage. So what we might do is we might just dump data in, right, in its format. And it might come in something like this. And then as you see, this data, the sales ID on this column is wrong. This is missing a lot of data here. This row, this date is in the wrong format. So what we'll do is we'll just copy the data kind of as is, and we'll see that there's a lot of missing and there's a lot of wrong data in this. So we'll keep kind of this raw format, and then we might take another copy of the data into kind of the next layer and say, okay, well, we're just going to clean up the data. And then that will happen is we'll just kind of remove these bad data. We might fix some data validation. So we can do all this data validation in the Lakehouse as well. It's a bit easier to do as well, because we keep the raw data. We just say, okay, and then we can copy and make kind of this nice clean data set. After that, we might do some more transformations, add some business logic, kind of make our data ready for reporting maybe. So maybe I want to make it kind of in this format, adding some columns, doing some business logic, making star schema, all of this kind of stuff. And then we'll have another copy and say, this data set here, this layer is really good, and it's good for reporting, and it's trustworthy data. And this is kind of what we call about, this architecture in the Lakehouse. Really, really common one you'll come across is what we call kind of the medallion architecture. Doesn't matter too much. It's really just this concept of having these different layers, taking your data through kind of a process to get it from, the data, which is never in the clean format, always data quality issues, having a process then to clean it and to kind of make it available to the business.
This is a really great point, Steve. And I also want to point out something really clear here too. You said the word copy, and yes, we are copying the data potentially in multiple times. But again, I want to be very clear here. When you think of the world as a SQL server, you are very opposed to having multiple copies of the same data, because that is so against efficient storage of information. And I want to be very clear here. Because the storage costs are so cheap compared to what we'd be doing typically on a SQL server, it's not a bad thing for us to keep that extra data around. For comparison, as of today, roughly around, you can store 1 gig of data for a year for 21 cents. I mean, that's pretty stinking cheap if you're going to store some data. So, the concept of having multiple copies of data, yes, they're copies of data, but you noticed as Steve walked through that example, there's cleaning happening. There's rows being removed. There's transformations occurring. So the reason we do this is we can spend one moment in time to compute the data we need to, store it efficiently for reading later on in Power BI. So this is a very key concept. And so I don't think of it as like a copy in the traditional sense. Think about it as an enhanced copy, a enriched copy. It's making the data better than what it was in that initial copy layer. So I just want to be very clear. A lot of people get their head stuck around like, well, I don't want to make so many copies of data. That's not the issue here, because you have built a data pipeline that can allow you to create that raw layer, a cleaned layer, and then that final transformed star schema or enriched layer for your reporting. So again, I just want to be really clear about that as well. It's not a bad thing to have multiple copies of data.
Yeah, that's a great point. And thanks for clarifying. And, I like that. And as you say, it's an evolution of the data, right? We're not simply copying the data, as you say. Each time we're doing something, we're making it better. As the advantage there is, we can go back, we can always see at any point in time kind of the data. Sometimes you might just need the data in its raw format, and then it's there and it's very easy just to kind of jump into. As you say, but we've evolved the data. This is where we need some sort of architecture in place, and we call these layers, you'll hear the medallion architecture a lot, the most common, but kind of whatever you want, right? But you have an architecture in place, have a structure, so that we know we're not just randomly copying data. This is an evolution of data, and in each stage we're getting closer and closer to this kind of gold standard and what we want for our specific processes.
Excellent. Well, with that, we thank you very much for listening to our first episode here. There's going to be a couple more episodes coming. We're going to go deeper into this topic, but thank you very much for listening for this introduction on lakehouses, and we'll do a couple more in the next couple of weeks. So stay tuned. There'll be more videos coming, and we'll link them in the description below.
Thank you very much.